Hey everybody! This lesson we're going to be talking a bit about coloring objects as well as creating our own custom colors. We'll start off by looking at the use of the predefined colors which we've been using so far. As you can see in front of us, we have a red cube with side lengths of 2 in the viewport. On the left we have the simple code which creates our cube, colors it, and displays it. Remember, the color command takes two parameters, the object to be colored and the color to give it. So far in the course, we have tried to show you some of the predefined colors which are available to us. See, here we're using red. Remember that these predefined colors are in all caps and highlighted like red currently is here when they are valid colors. For example, let me change red to green. It's highlighted. Our cube is now green. Or we could change it to blue, one of the other primary colors. But beyond these three primary colors, there are other available palettes of colors, or just groups of similar colors. There is the metal palette with colors like silver, gold, and copper, which I'll show to you by showing you gold. As well as silver, and then there's others which are not metals or just the primary colors. For example, one palette is ice cream flavors. I can show you a color like vanilla, which belongs to this palette. Or even a mint. So though NCLab provides you a lot of nice colors that you can give your objects that are predefined, the really cool part comes in when we make our own colors. Let's restructure our program a bit so that we can do this. Let's define an array up above which contains the comma-separated value 0, 0, 0, named myColor. An array is made using these square brackets here. I'll explain more what an array is, as well as what these values are, in just a moment. Now let's replace the second parameter in the color function with our new variable, myColor. What we've done here is created a custom color, myColor, and applied it to our object. This array that we made is essentially a list, which holds three different values. Each of these values represents the amount of each color created in it. Specifically, each of these colors represents the amount of red, green, and blue in the total color, which myColor represents. Our custom color has 0 in each of these categories, which creates a black color. Let's run the program so we can see it. And here is our very black cube. Each of these numbers can range from 0 to 255. Which gives us 256 possible levels for each of these colors. If we change all of the values in the array to 255, the maximum, we can expect a white color. Let's try it and run our program to see it. As we anticipated, our cube is now completely white. When all of the primary colors are mixed, they create this white color. So let's play around with the primary colors. The first value in this array represents the amount of red in myColor. What happens if we put a 100 in here and then zeros in the other spaces? So you can see it gives our cube a very dark red color. So let's increase that to 200 and see what happens. It is now a much brighter red. So let's just bump it up to the very maximum value, 255, and see what happens to our red. Now it's a very, very bright red. You can tell now that the value in each of these parts of the array represents the brightness of that particular color. This combination of three numbers in the array is called the RGB code, with RGB meaning red, green, blue. It's important to know this because the order of the numbers in this array is the same as the order of the colors in RGB. So if we put the second entry to 255 and the other entries to 0, it should be at the maximum level of green with the minimums of other numbers. Let's try that out and run our program. Our custom color, my color, now represents a very bright green, and it's coloring our cube a very bright green. Let's do the same thing with the third entry in the array, representing the blue color. Let's change all to 0 and the last to 255 and run the program. Now there is no red and no green in the color, but it's all blue. Now let's mix some colors to make some of the secondary colors. If we put the maximum 255 for red, as well as the maximum 255 for green, and then we bring the blue balance back to a 0, we should get a nice bright yellow. And like we thought, a bright yellow. Let's try one more. Change my color to 255 red, 0 for green, and then 255 for blue. Once again, 255 being the maximum. Our mixture of 100% brightness for red and blue with 0 green created this pinkish purplish color. So there are a lot of different colors you can make using these RGB codes. In fact, the number of combinations is equal to 256 multiplied by 256 multiplied again by 256, which ends up being around 17 million different potential color combinations. You can find new colors to give your objects with a quick internet search for RGB palettes or RGB codes, or just searching in RGB code and then describe the color you want. There are many tools and lists to help you select RGB codes. One cool one is the website Color Schemer, which I have here in another tab. Say I like this blue right here. I can click on it, and then right here it has an example of it as well as the RGB code for that particular color. If I want to implement that in my program, I can take this RGB code here, I can copy it, and then I can paste it in here. Notice that this is now a period separated list instead of a comma separated list, so I'll just put it back to commas so our program can read it and run our program. And we have now created a blue cube with a color that we got from the internet. So to summarize this lesson, let's review a few things. We can create custom colors using an array with three numbers in it. The first represents the amount of red in the color, the second represents the amount of green, and the third represents the amount of blue. The higher that each of these numbers is, the brighter that each color will show in the total color which the list represents. Remember also that you can use a search engine to research colors and find their RGB codes. Experiment with these colors and see what kind of shades you can make.